All right, so the final thing I'm going to share here with inequalities are using and or conditions with the inequality. So what does that mean? And means that you have two separate inequalities, and you're going to find the range of answers that make both those inequalities true. So there'll be a range of numbers that make both of the inequalities true. An OR condition means answers that make either one of those inequalities true. So and OR are very common in computer science. They're very common in computer science terms. And means both conditions have to be true, and OR means either one of those conditions, either one of the answers to either of the equations can be true. They both don't have to be true for that equation. Anyways, so let me go ahead and give you two examples of the AND operation. The first one here is negative 12 is less than or equal to x minus 6, which is less than or equal to 0. All right, so let me read that again. Negative 12 is less than or equal to x minus 6, which is less than or equal to 0. So this might be the first time you've seen it's an equation broken up into three pieces instead of just two. There's two different signs here. If you feel more comfortable, you could break this up and just say negative 12 less than or equal to x minus 6. That's one problem. And then the other problem would be x minus 6 less than or equal to 0. So again, you can make this one problem, negative 12 less than or equal to x minus 6, and x minus 6 less than or equal to 0. So basically, we're just going to solve both of these inequalities and graph the solutions that make both of them true. The other way we can solve this is just keeping it in this form, and just when we add or subtract or multiply and divide anything, we do it to all three sections. So that's what we're going to do. Just go ahead and take a look at that. So again, the variable is here, and we have to isolate the variable, meaning we need x by itself. And right now it says x minus 6. So what we need to do to get rid of the minus 6 is do the inverse operation, which is plus 6. And if we plus 6 here, we're going to plus 6 on either side of these equations as well. So we're going to plus 6, negative 12 plus 6. We're going to plus 6 to the x minus 6 here, and then the 0 plus 6. And if we do that, we're going to get negative 12 plus 6 is going to be negative 6, less than or equal to x, which is because negative 6 plus 6 is 0. And then 0 plus 6 is just 6. So the final solution is going to be negative 6, less than or equal to x, less than or equal to 6. And again, when we graph this, we can separate it. We can make it negative 6 less than or equal to x. And like we've been doing in the past, I can flip these around and flip the sign. So it would look like this. X is greater than or equal to negative 6. And the other side is x is less than or equal to 6, which is right here. So if we graph this one, x is less than or equal to 6. It's a closed circle because of the equal sign. And this less than or equal to 6 would be this direction. And then for this one, and this would conclude everything on this side past the arrow as well. And for this one, x is greater than or equal to negative 6. Here's negative 6, and it's greater than or equal to 6, so it would go all the way here. But because we want the range of solutions that make both of these equations true, it's going to be between this, and that would be just the solution set. So independently, this would go all the way over here. This one would go all the way over here. But because we want where they intersect, where both solutions are true for both equations, it would just be this range. All right, let's take a look at another example here. 4x is less than 16, and x minus 12 is greater than negative 15. Okay, and in this situation, we're just going to solve each inequality independently and graph them independently, and wherever they intersect is where we're going to, that'll be our final solution because this is an AND. So for this one, I'm just going to divide both sides by 4. Because we have a 4x here, it's multiplied. I'm going to divide by 4. So 4 divided by 4 is going to be just x. And then 16 divided by 4 is going to be just 4. So it's going to be x is less than 4. And on this side, I'm going to add 12 to both sides of the equation. So x minus 12, I want to add 12 to both sides. When I do that, I'll have here negative 12 plus 12 is 0, so I just bring down the x. Greater than negative 15 plus 12 is going to be negative 3. Remember, we have a negative and a positive. We subtract them, the smaller from the larger, so 15 minus 12 is 3. What do I have more, positives or negatives? I have more negatives. I have negative 15, only positive 12. So my answer is negative 3. So now I'm just going to graph both of those. X is less than 4. So I go to the 4, it's an open circle, and it's everything to this direction, to the left. X is greater than negative 3. Negative 3 open circle. And if I follow the arrow, it's this direction all the way. But again, I only want when the and condition where they intersect. So the 4 going this way, then the 3 going that way. The solutions, when they're both true, are in between. Generally, that's how your and conditions are going to look. They're going to have just a range of numbers between the two. All right, let's take a look at some OR examples. This over here. Hope you can see that. All right, so I just have here one example. X over 5 is less than or equal to negative 2, or x over 4 is greater than or equal to 5. So just like we did with the and, we solve both of them so that we just have the variable by itself so we can graph it. And here, remember, x over 5, this is dividing, so the opposite of dividing is multiplying. So I'm going to multiply by 5 on both sides. And that's what I'm doing here. 5 times x over 5 less than or equal to negative 2 times 5. Because I'm multiplying this side by 5, I'll multiply this side by 5. And we're multiplying by a negative number, a positive number, so we're not flipping the inequality. So now here, 5x over 5 is going to be 5 over 5 is 1. 1 times x is x. Less than or equal to negative 2 times 5. Negative times a positive is negative, so negative 10. X is less than or equal to negative 10. Or, if we go on this side of the equation, we have x over 4 greater than or equal to 5. Again, I'm dividing here, so don't let this intimidate you. All you have to do here is the inverse of dividing is multiplying. So it's a little easier. I multiply both sides by 5. I'm not going to do division here. Multiplication is easier. So if I multiply both sides by 4, I multiply both sides by 4. X over 4 times 4, 4 over 4 is 1. 1 times x is x. And then 5 times 4 is 20. So x is greater than or equal to 20. Now I'm going to graph these. I'll go to this one first. X is less than or equal to negative 10. So here's my negative 10. If you look at the direction of the arrow, it's a closed circle because of the equal sign. I go this direction. Or x is greater than or equal to 20. Here's the 20. X is greater than 20, so everything to the right of 20. Closed circle. And my OR condition, both conditions have to be are true, even though they don't ever intersect. So this is what my final solution would look like. Every number less than 10, negative 10, and every number greater than 20 would make either one of those solutions true. Okay, thank you.